चलो दोस्तों शुरू करते हैं without wasting a time. As we have seen the last topic is that how RR provide the suboptimal path. So in this video we'll discuss about how we can place the RR, what are the different options we can do actually, what are the different things we can do so we can get the optimal path. So in this topology we can see that we have an eight pop location on each pop location we have an a 2P router, we can say two provider routers. So here we can see that we have in this east pop locations. Behind this east pop location, we have this prefix is coming 1.1.1.1. And similar way, behind this west pop location, we have the same prefix is coming from this location also. In this topology, if you plan for the centralized RR, if I place the only one RR and peering all these pop location router will become the router of the client with this RR. So what will happen is this RR will provide the suboptimal path. When I say suboptimal path is this way. Let's suppose east this east pop have also advertised this 1.1 prefix to this RR, and this west pop will also advertise this prefix to this RR. Then after that RR will run the best path calculation. Let's suppose you have selected the east pop location, this network best, okay, as this is closest to the RR. Okay, this is selected the this prefix and next stop is the pop PE1. Okay, now the problem after that RR will reflect this best route to the all of the pop location. Okay, so north pop 1 location will also get the best route, okay, for this one prefix from this location, and north pop 2 location will also get this route from the this P1 also best route. So every location will send the traffic to this. Okay, the problem in this topology we can see that however this north pop 2 location is very nearest to this west pop location. Ideally what should happen is this for this location traffic should go to the this way. So this is the way RR is providing a suboptimal path. So in this kind of topology, on this kind of network, centralized RR cannot be the solution, correct? So we can place it, but we'll get the suboptimal path, will not get the optimal path. So let's start our first traffic type is that is the traffic for the intra pop between the pop. In the pop, every pop we have two locations, pop P1 and pop P2. Let's show us how the traffic will flow, how we can get the optimal path while the traffic flowing from the pop to intra pop location. Okay. Let's suppose for to get the optimal path for the intra pop traffic, if we go with the each for each location pair of the RR, like I have put the pair of RR here for the east pop, similar for the pop 2 location I put the pair of RR here, also pair of RR here, also pair of RR. So total pair of RR will be required. The 1, 2, 3, 4, 5, 6, 7 pair of RR will be required as we have a 7 pop location. Okay, so now the bigger problem is if we put the pair of RR for the each location and then we have to do the full mesh peering between the pair of RR. So this number of peering required will be count will be very high. Actually, it will be very difficult to manage. Correct. So this will be the another problem. So instead of putting the pair of RR for the each pop location, what we have do is we can do the merge to the pop location. Like we have an east pop location 1, east pop location 2. I have merged these two location. Similar way for the south pop, I have an merge, and west I have kept as it is, and north also pop I have merged these two location. And after that I put the regional RR. So earlier we have an 8 pair of RR. Now we have an only 4 pair of RR, and now we can go with the full mesh peering with the between the regional RR pair of router, correct? But then this very small topology also we can see that now we have an only 4 pair of regional RR. That means total 8 RR router. And if we go with the full mesh peering between them to get the optimal path, so what will happen is only with the small topology, only with the small number of 8 RR reflector, we still need a 28 IBGP session. Okay, here we are taking the example of very small topology. In the bigger network, this will be the still the issue. So what we can do is, so to solve the IBGP session problem between the regional RR, what we can do is we can place the central RR for the each location, like for the east pop location. For this regional RR, here put the one central RR here also, one central RR here also, one central RR here also. and for this region also I put the one central error, and between these four central error we can do the full mesh peering. So ultimately this will solve the peering session problem, and by putting the regional error we have solved the problem of the intra-pop traffic. One another way we can solve this intra-pop traffic is what we can do is we can do the full mesh peering between the pop location, like pop 1 and the pop 2 location, all of the router we can do the full mesh. Here in the north pop 1, pop 2, all of the P location we do the full mesh. Here in the west pop also we can do the full mesh. And in the south pole location, all four router also we do the full mesh peering in the pop. And after that this all client router will reflect the route to the regional RR, correct? And regional RR, and we don't as we have a full mesh peering between the pop locations, so we don't want this route reflect regional RR to again reflect the route to the, like let's suppose this P1 advertise will route to the regional RR, then regional RR will again reflect the same route to the pop location. This is not required. So what we can do is we can disable the client to client route reflection on the on this regional RR we can disable. And second thing, same way as we have already done the full mesh between the pop location routers, so route will come to the route reflector, regional route reflector, and regional router will reflect to the other regional reflector on the same location as each location will to regional RR. So between the RR, between the regional RR also reflection not required. So there will be no peering required between the regional RR, and then no client to client communication will also will be not required in that case if we go with the full mesh peering at the pop location. And to control the traffic between the inter-pop location from pop 1 location to pop 2 location to get the to get the optimal path, we can use the BGP additional path feature and BGP external. So BGP additional path feature will advertise the multiple path for the same prefix. As we have seen that normally route reflector will reflect the only best one path, but with the help of BGP additional path feature, we can get the multiple path for the same prefix. On the high level, we can say that BGP add path will work as a like identifier to the each path, like we use the RD in the Empress VPN to make the unique prefix. Correct. Same way, BGP additional path feature add a unique path ID to the each path, so we can get the multiple path for the same prefix. In the next lab, we will see how we can implement the BGP additional path and BGP external together to get the optimal path between the two pop location, to get the optimal path for the traffic between the two pop location.